In the earlier lesson on part 5 of the video, I talked about reflection in y-axis. Now this part talk about even function or odd function is closely related to reflection in y-axis. We say a function is even if f of minus x is equal to f of x. In this case, the graph of f of minus x is the same as the graph of f of x. For example, f of x equal to x squared is an even function. Why? Because f of minus x equal to minus x squared is still equal to x squared, which is equal to f of x. So f of x equal to x squared is an even function. If you look at the graph of y equal to x squared, you'll find that the graph is symmetrical about the y-axis. So for an even function, the graph is symmetrical about the y-axis. Similarly, we have also odd function. We say a function is odd if f of minus x equal to minus f of x. That means that f of minus x and minus f of x have the same graph. Example of an odd function is this. Look at minus f of minus x. Now f of x is x cubed, so f of minus x is minus x cubed. And after you cube this, you get x power 3 again, which is the same as f of x. So f of x equal x cubed is odd. Now what is so special about the graph of odd function? If you try to look at the graph of odd function, say the xy axis, in particular y equal x cubed, if you look at the right side, well, x less than 0, for odd function, you can get the graph on the left side by doing double reflection. That means you do a reflection in y-axis first, then you do another reflection in x-axis. So that the graph on the right hand side is this piece here is exactly the same on the graph by doing reflection in y-axis then reflection in x-axis. This is also called the graph is symmetrical about origin. Okay, now next I want to talk about scaling, another transformation of the graph, so that equations are closely related. So I have the graph of here y equal to sine of x. Let's say I have another equation y equal to 2 sine x. Now this is what we call a vertical scaling. So if you multiply all the y by 2, then you expect the graph will be all the value of y times 2. So all the value of y times 2, and you are going to get something like this after you multiply all the value of y by 2. So 1 become 2, minus 1 become minus 2, 0 becomes 0, and so on. So this is the graph after you multiply all the value of y times 2. In fact, you can check by arithmetical. This is the graph after I have the graph of y equal to sine x and the graph of y equal to 2 times sine x. Now, what happens if you have y equal to half times sine x? How does it look like? Now, if you have y equal to half sine x, then how does the graph look like? Let me use a different color. So then all the value of y will multiply by half, so you get 1 become half, 0 is still 0, minus 1 becomes minus half, and you have the graph like this now, half the size. of the value of y. Okay, so this will give you the blue curve, give you y equal to half sine x. These are all about vertical scaling. Now, can we have horizontal scaling? We can also have. Now, what happens if I change the x to 2x? Say, for example, let's say I have the graph of, say, change the x to 2x. How does the graph look like? Now, you can get the same graph by rescaling the x-axis. So how do we rescale it? All the value in the x-axis divide by 2. So 2 pi divided by 2 we get pi. Alright? And then pi divided by 2 we get pi over 2. So by doing so, then you get the same graph look like this. 0 to pi over 2 to pi. And you get this graph come out. This is the graph of y equal to 2x. So instead of ranging from 0 to 2 pi for the red curve, now the black curve will be, it look like the same curve but range from 0 to pi. Now putting it together, this is how it look like. Y equal to sine 2x. So from 0 to pi, you have one cycle. Then repeat again. So this time, you get 2 cycles from 0 to 2 pi. This is how you get the graph of y equal to sine 2x. Now you can make a comparison by looking at y equal to sine x and y equal to sine 2x. Let's draw a picture. This is the graph of y equal to sine x. From 0 to 2 pi, you get one cycle, y equal to sine x. Now, what happens if you have y equal to sine 2x? Then you get this curve come out. Now, you may wonder, what happens if I have y equal to sine half x? To get the graph of y equal to sine x, right? For y equal to sine x is like this, 0 to 2 pi, minus 1 to 1. This is y equal to sine x. Now, if I change the x to half of x, and this is again a scaling. So what you do, you divide all the scale on along x-axis by half. So divide this by half, what you get? You get 4 pi. Divide this by half, you get 2 pi. Divide this by half, 0 by half, you get 0. So the whole curve will change to something like this. Let me redraw using a picture. If you want to get y equals sine half x, this is from 0 to 4 pi now. Instead of 0 to 2 pi, in the middle is 2 pi. And you get a curve like this. And then you have a curve like this. From 0 to 2 pi, then to 4 pi. You get a complete cycle. And this is the graph of y equal to sine half x. Now, if you try to figure out how does it compare to y equal to sine x, imagine y equal to sine x is actually here. From 0 to 2 pi, there is one cycle. So y equal to sine x is this pi. Okay, then another one. Okay, y equal to sine x will be this one. Okay. So in summary, you can see some of the picture here about horizontal scaling and vertical scaling. So if you have y equal to fx and you multiply by k is a number, then this is about vertical scaling. When if you have y equal to f of x and when you multiply the x by a number, kx here, This is a horizontal scaling. Finally, I'm going to introduce a special function. This special function is called a greatest integer function. This is a greatest integer that is less than or equal to x. For example, the greatest integer less than or equal to 2.75 is 2. The greatest integer less than or equal to 3 is 3. The greatest integer less than minus 1.8 or equal to minus 1.8 is minus 2. It must be an integer. Alright. And how does the graph look like? You can see that the graph looks like a staircase, a lot of steps. For example, if you try to see the picture, let's say x between 3 and 4. Then, what is the greatest integer less than equal to x now? If x is a number anywhere between 3 to 4, you know the most is greatest integer less than or equal to x. The most is 3 now. If your x between 3 and 4, for example, greatest integer less than or equal to 3.3 is 3. Greatest integer less than or equal to 3.9 is still 3. So if you have a point anywhere between 3 to 4, the greatest integer less than or equal to a value of x where x between 3 to 4 will be 3 solid here all the way to excluding 4, right? Because when x equal to 4, the greatest integer less than or equal to 4 will be 4 already. That's the end of the recording.